Hey, this is Mr. Beckstrom, and today I want to take a look at from section 1.2. This is number 33, and this is graphing a piecewise function. And this is a function that's graphed in multiple parts. So it's usually not going to be a continuous function, and usually it's not going to be kind of a differentiable function, which we're going to define later in this class. It's very often going to kind of look weird, and it's going to have maybe edges and spikes and points and things like that. So let's go ahead and graph this and see what it looks like. So the first thing I like to do is I like to see the breakpoints. At what x values does this thing change graphs? So it looks like it changes at -1 and +1, and I can see that on the right hand side here. So if it's x is less than -1, if it's between -1 and +1, and if it's greater than +1. So what I'm going to do here is I'm going to mark off, I'm going to make this value here -1. I'm going to make this value here +1, and then I am going to do a little dotted line, a vertical line going down, not a very good one, but for -1, and then another vertical line going down for +1. And the reason I do that is because the graph on this side, or the curve on this side, is quite possibly going to look different from the curve between these two vertical lines, which is quite possibly going to look different than the curve on the right side of this vertical line. So these vertical lines are going to kind of change what this graph is going to look like. And also the strict inequality, which is strictly less than and strictly greater than, is going to be a little bit different than the less than or equal to is here, which means that when we're talking about the curve between these two lines, notice that you have the equals in there, which means that we're going to have solid points when we're talking about the curve in between there. And then when we're talking about the curve to the left, which is less than, and the curve to the right, which is greater than, it's a strict inequality, which means that we're going to have open holes. So let's start and take a look. So this first one is if it is less than -1, which is to the left of this -1 vertical line here, so we're talking about the area over here, then we have the function -2x minus 1. So that's what it's going to look like. We're going to look like y is equal to -2x minus 1. So if we were right at -1, let's put -1 in there and see what we get. So f of -1 is equal to, plug a -1 in there, so -2 times -1 is 2, and 2 minus 1 is 1. So if we go up here to 1, it looks like it's going to be right here, so I'm going to put an open hole. And it looks like our slope, since this is in y-intercept form, is -2/1, so we have a slope equal to -2/1. So that means we go down 2 and to the left 1, right? Or, no, I'm sorry, that would be a positive slope. We go up 2 and to the left 1, or we go down 2 and to the right 1. So if we go up 2 and to the left 1, it's going to be somewhere over here. It's going to be kind of a steep slope. So this is going to be kind of going up pretty steep going this way. So this is what it looks like to the left of this vertical line here. Let's go down to the, I'm going to kind of separate this one here. Now let's look between -1 and +1 here. Between -1 and +1, we have a graph that looks like this, y equals 1. And y equals 1 is just a horizontal line where all of our y values are 1. And remember that we have non-strict equality, which means it includes those points. So this thing here, so actually we're going to end up filling in this point. So it's just a horizontal line where every value all of our y values are 1, so it's just going to go from here to here, just like that, and we fill in the value. So it actually connects here, and it doesn't always connect, but it does in this case. And that's it for that one. And now we're going to look when x is greater than 1, so that would be to the right side of this vertical line where x is equal to 1. So we have y is equal to 2x minus 1. So once again, let's go ahead and see what happens when we plug in a 1 for x. So f of 1, so 2 times 1 is 2. 2 minus 1 is 1. So we get, I should have put 1 over there, right? And so f of 1 is 1. So it looks like we're going to start here again, and we have a slope of 2 over 1. So slope of 2 over 1, which means we have a positive slope that goes up 2 and over 1. So we have a slope that it's a little bit steeper than that. Let me redo that one. So kind of like maybe even, let me go just a tad bit steeper to kind of match the other side there. All right, well, close enough. Now we would put a hole here, but it's already filled in from this y equals 1 from the middle. So kind of a neat design there, but this is a piecewise function, and this actually happens to be continuous because we can actually draw it without ever lifting the pencil, and we will define continuous pretty soon. So but there are many piecewise functions that are not going to be continuous, so don't expect all of them to. They just designed this one so it happened to connect at every point here. All right, if you have any questions, let me know, and look forward to hearing from you.